Humans have always reached for the stars. And in the 20th century, determination and technology brought space within reach.
Space is going to be ubiquitous in our economy. You can't run away from the space industry.
そういったその地球上での食の問題、資源の問題、QOL の問題、クオリティオブライフの問題ですね。
Now, space might just help humankind survive.
By doing something in space and making it robust there, we're actually preparing it for Earth and making something that can last into the future.
The Netherlands is one of Europe's smallest nations. But despite limited land, the Dutch mastered agriculture. Only the United States exports more food. Research and innovation enabled Dutch farmers to make the most of limited resources. The science behind those advances largely emerged here at Wageningen, southeast of Amsterdam. The city's university is the country's premier agricultural institute and the scene of cutting-edge food study. Professor Wieger Wamelink grows crops as if he was farming in space. He plants green beans, potatoes, and other food crops in a custom mixed soil that mimics the chemical and physical properties of the soil on Mars.
If you see here, we compare the green bean. This one is on Mars soil simulant. This is on Earth control. You can see it looks more or less the same, but the Earth control is still on potting soil a bit bigger, and you'll see lots more roots. That's very obvious. So the harvest on Earth potting soil is still higher, but this one also forms nice green beans. So we have a harvest, but well, this is still a little bit less, and we want to improve that so that it's the same. We've got over 25 different crop species that we can grow at the moment. The potatoes, for instance, they are doing very well. They look like normal potatoes, no different from what you would harvest on your field. So they're doing very well at the moment, as long as you manure them. So we need some kind of manuring, because we are lacking nitrate and ammonia in the soil, essential for plant growth. And as long as we can provide the plants with that, then it's going very well.
This manure is human waste. Composting converts it into safe, nutrient-dense fertilizer. Wamelink's student Raf oversees the so-called pea and poo experiment.
The Martian regolith misses some components like nitrogen or available phosphorus. And therefore we thought, okay, we can bring that as well to Mars to potentially colonize. But if you bring stuff like that, it means you use space in the aircraft that can be used for other stuff. So why don't we use something that we already have? And that can be seen in human excreta. Urine and feces, for example, are filled with nutrients that plants can use. And this is what we try to do with this experiment.
We're going to use on Mars our own poo and pee. My grandfather, I still remember, did that. So once a year, he was emptying the hole in the ground he had, where it was all collected, was putting that on his garden. And when we came as children, we could see that he had done it because some of the toilet paper then was still sticking out. But he was growing his own vegetable on his own poo and pee.
Sustainable practices of the past could inspire the farming of the future, on Earth and in space. For nearly 10 years, Dr. Wamelink has been envisioning a way to grow crops on Mars. The red planet's harsh environment, lethal radiation levels, extreme temperatures, lack of oxygen and water, and low gravity argue against trying to settle on its surface. So the idea is to burrow underground and build enclosed, self-sustaining settlements. Inhabitants would live and work in modules, feeding themselves by farming vertically as Earthlings already do. The challenge is to devise a system that combines all the elements of agriculture, light, water, seeds, energy, and nutrients, while sustaining itself.
I hope that we learned a lot from our Mars and Moon experiments and that we can also apply it here on Earth, making agriculture circular again. That will be one of the main goals for 2050, because we now are not circular and we're using a lot of resources from other parts of the world and actually depleting the resources over there. And that also causes major problems here in the Netherlands because nature suffers from it. So I hope that by 2050 we can have it circular again and that we know what is needed to have a healthy soil again to make it circular. Growing crops alone is not enough. Because when you eat something, you don't eat everything. If you have tomatoes, you only eat the tomatoes, not the leaves, not the roots. And you have to recycle that because it has to be brought back in the system because there's nothing there. So nothing can be lost.
Researchers worldwide are studying farming in space.
215.
Channel 8, please.
Some are using what they have learned to reboot traditional earthbound agriculture. Melbourne's Queen Victoria Market is a cornucopia of locally grown produce. All that bounty inspired a homegrown startup, aiming to make agriculture more sustainable.
I came from a corporate environment, working big hours, and I think one of the critical things I thought I should do would be spending my time wisely. So I thought working on something that can better the planet would be the ideal pathway. So I kind of worked on a lot of platforms, such as renewable energy in Southeast Asia, and slowly came around greenhouse farming.
The Gaia Project's newest greenhouse is in the heart of Melbourne. The intelligent crop cultivation module is designed for use in space, specifically aboard a shuttlecraft. NASA is underwriting work on the unit.
We're looking at 9 milligrams per litre.
It's an ultra-compact farm that's highly engineered. With light, temperature, and air quality tightly controlled, team members germinate vegetable and microgreen seeds in a growth medium. After 3 weeks, the seedlings go into the main cultivation area in modular channels. A mobile device irrigates the plants, delivering nutrients and oxygen and maintaining the proper pH. Water and nutrients come in one way, waste materials leave by another. The tank cleans itself with an ultraviolet sterilizing system. Once programmed, the system practically runs itself.
Efficiency-wise, our systems are 100% more yield comparison to any other systems in the market. Now, saying that, there are companies who produce around 50 plants per square meter with additional support. That includes either robotics or labor. Now, some of these components carry things like high contamination, plant transplanting, and a lot of the other things which we don't need to do. It's a singular channel, simple solution that provides what you need without the requirements of labor or capital.
As plants grow, the channels widen and lengthen to make room for them. This feature is meant to conserve space in space, where space is limitless, except aboard a spacecraft.
For space travel-wise, if you look at a space shuttle, every shell, every square centimeter of a space shuttle is significant amount of money. And currently, we're the ones that can provide a solution for the astronauts with using the lowest amount of space inside the spacecraft and using the lowest amount of water and also the lighting. And ideally, that's what they're looking for in a spacecraft. If you look at building a habitat in Mars, you have to build a complete enclosure, and you have to make sure that what you build inside has the highest efficiencies. We built it for a crew of 4 astronauts, and the system able to provide each astronaut daily around 150 to 200 grams of a combination of leafy greens and microgreens. And that kind of gives us an average output every month or every 28-day cycle, around 16 to 20 kgs. If you get to work with plants or get to touch them, plant them, harvest them, that kind of gives them some closeness to the planet that they're missing. And when they're out in the space where there's nothingness, I mean, that's one of the closest ways you can be close to planet Earth, I would say.
The team is scaling down a version for use on Earth, in Earthling homes. The refrigerator-sized modules would fit into urban dwellings. Powered by renewable energy, they would keep households stocked with leafy greens.
If a lot of people adopt these technologies, you don't need to have trucks running from one corner of the country to another corner to provide food. And you don't have pesticides or insecticides in your food. You know what you grow. Because everyone lives in urban areas now, mainly in apartments. You don't really have a backyard in your house. This would be the next ideal solution for the 21st century. System set up on the roof end. We're still planning on the original system where you connect our inlet systems into the main.
90 minutes from Melbourne, the team visits farmers. One is a top grower of iceberg lettuce.
Yeah, so 1 more week to go.
Yeah, that's it. Then harvest time.
I can't believe they survived the flood so well.
I think these guys are on the higher ground.
Yeah.
Week away from harvest. So it's got a beautiful head, the leaves are really big frame. Oh, in the last few years, it's been very challenging. We've had a lot of rain, especially the last 2 or 3 years. It has completely changed us on the way we've been growing. Variety changing to compensate the climate, being too wet or too cold versus being hot and dry in the drought times. Yeah. So it's been unreal.
These plants have evolved to grow in predictable climates, and it's just not there. So climate change is really impacting our food security. And then moving forward with an exploding population, how are we going to feed that population? And these farmers have got a hard job. I think in history we had to do agriculture because that's the technology we had and we had to survive. So we can't feel guilty about that. But moving forward, we need to decouple agriculture from the land if we can, as much as we can. So then we don't have incorrect use of non-renewable resources like your fertiliser and your water, and even your labour and land. So if we decouple from the land and use it more efficiently, now we're starting to have like a circular economy rather than a linear one, where your inputs go through the farm, they become outputs and they're wasted and polluting the ground, they become the inputs again. If you think about space, space is finite, very finite. You have to use what you have. The Earth is no different, we just think it's different. So by doing something in space and making it robust there, we're actually preparing it for Earth and making something that could last into the future. So it goes hand in hand, agritech and space, make a good product, bring it back and help humanity move forward with some food security.
I think if you look at your everyday equipment, you use something starting from the microwave, you look at your GPS that you use, your mobile phone technology, everything is built for space at one point, and then somehow it ended up in planet Earth. I think that's the idea of technology development. If it's good for space, then it sure is good for Earth.
The race to grow food in space extends to Bangkok, Thailand. Plant biologist Tatpong Tulyananda works at Mahidol University.
When I was young, just like every other kids, there are 2 things that most kids are interested in. dinosaurs and space, and I'm more of a space guy. So when I got Thai government scholarship to study abroad, at first I want to really study about space farming. So maybe I can adapt my research from general plant adaptation into space environment.
Tat Pong studies watermeal, a highly nutritious water plant.
So for Asian watermeal in Thailand, we have been using this plant since maybe 100 years. In northern Thailand and northeastern, we use it as vegetable. It's the fastest growing plant on earth. So fast growing plant mean you can produce in very high volume in a very short period, right? People start to study the plant, then they found out that the plant is very nutritious with all kinds of things that humans need.
Fast growth and high nutritive value could make watermeal a superfood and a promising candidate for cultivation in space. After years of studying watermeal, Tat Pong is going to actually taste the stuff.
Yeah, I like it. I think watermeal adds some texture into the omelette. If you tell the people what is watermeal and how nutritious it is and how it's good for you, yeah, I think it might be popular. I like it. Okay, so you see the watermeal on here, right? It keeps growing very fast. But then, if you want to work
To grow watermeal successfully in space means knowing how the plant responds to changes in gravity.
The challenge is that how can we create hypergravity long enough for plant to grow in full cycle, that we can study the growth rate, the plant response to hypergravity environment, and so many things, the physiology of plant basically.
A centrifuge simulates hypergravity. That's gravity greater than Earth's. Hypergravity harms most plants, but Tat Pong's tests show watermeal faring better. In short tests, the plant sinks, but afterwards, watermeal grows normally with no apparent harm.
The goal is to understand, well, if in the future, if we want to grow plant in huge planet, like for example, Jupiter, maybe we have to understand how plant react into hypergravity environment.
Tat Pong has other projects running. Thailand conducts experiments at its Geoinformatics Space Technology Development Agency, or GISTA for short.
Food is very important in the near future because we have planned to travel, explore the new planets. So that's why you have to find the food is suitable to grow in the spaceship, to provide you the oxygen, and the weight for the food is very important. So the space experiment here facility to set up the protocol and find the suitable plants to for the long journey.
GISTA houses one of the country's small number of clinostats, devices for simulating low gravity or microgravity.
We found that microgravity did not affect watermeal growth. And I have a hypothesis, maybe because watermeal does not have a root or shoot that can be affected by gravity. And watermeal is just a floating aquatic plant that can keep budding on the surface of water. Because watermeal is becoming a superfood on Earth, right? So if we find a way to increase the yield of watermeal production, maybe we can produce more watermeal as a food, especially for food security.
The inquiry could go beyond watermeal. Agriculture is among the pillars of Thailand's economy, and the country produces a profusion of edible plants.
We have very good source of plant variety and very good set of plant cultivars. So if we pick some specific plant that's suitable for a space application, Thailand can be the leader in terms of space farming. The reason space research is the catalyst for innovation because space makes impossible things possible, and we need to think out of the box in order to go to space and survive there. We need to try to find a way to grow plants in very extreme conditions in other planets. At the same time, if we can adapt it to somewhere remote on Earth, like in arid area or in extreme condition area like South Pole or North Pole, maybe we can produce food there and people over there can benefit from the farming technology we get from space.
Vegetables are essential, but what about other sources of nutrition? Scientists are working on a way to produce meat for space using far fewer resources. Meat appears in many diets, but farming the animals that become meat does much to warm the planet. Meat production generates nearly 60% of the greenhouse gases attributed to agriculture. Food production as a whole produces up to 31% of all greenhouse gas emissions worldwide. An Israeli firm is working to make meat more sustainable. Aleph is a cellular agriculture company. They make beef by cultivating it, a process that uses far less water and land than traditional herding.
We put the cells into a bioreactor, a tank that gives the cells the conditions that allows them to grow. We don't have to grow the whole cow or to feed the whole cow. We only grow the edible part that we really consume.
Climate change significantly impacts food security. And food security, in turn, impacts back climate change because when you need more food and you utilize more natural resources, and then come into play processes such as deforestation and water utilization, which in turn impacts back on climate change, and there's a vicious cycle. So to be able to stop the vicious cycle by reducing the dependence of food production on local resources would positively impact climate change as well.
Aleph is the world's first producer of cultivated beefsteaks. The steaks will soon gain regulatory approval for sale in Israel and Singapore.
Singapore is known to be very open to innovation and new technologies. And the reason for this is their need to find alternative solutions for the lack of lands and the lack of resources to grow animals in Singapore. And cultivated meat is really the exact technology that gets inside, because they can use these cells that we ship from Israel to Singapore with some ingredients that are produced in Singapore in order to create the meat without the need to grow the animals.
Aleph's method could enable meat production within cities, in arid settings, and on further frontiers. Aleph recently launched the Aleph Zero program with the goal of producing cultivated steaks in space.
Aleph Zero provides us the opportunity to tackle issues such as closed-loop production and near-zero waste production, and we can apply the lessons learned to our Earth activities over here in producing cultivated meat on Earth.
In 2019, Aleph Zero 3D bioprinted cow muscle tissue aboard the International Space Station. In 2022, aboard Axiom-1, the first privately crewed mission to the space station, Aleph reached further. The idea was to miniaturize their lab and send it to space, to see if cow cells could multiply and differentiate in microgravity. The test showed that lowered gravity had no significant effect on growing cultivated meat. Aleph used this technology for the experiment from an Israeli startup, Space Pharma. Space Pharma makes a telemetrically controlled miniature lab for use in space. Operators communicate with the system from Earth.
Within this chip, we install the stem cells and provide the nutrients, the temperature, the additives that generate the tissue culture, and that comes from Alpha. All the equipment that you see here goes into this little box, 3.4 kilograms, altogether. The concept that we adopt to build this system, which is called the SPAD, Space Pharma Advanced Laboratory, is first of all to make it very, very small, very miniaturized. And the reason for that is that even today, the cost of per launch, dollar-wise, it's so expensive. So if we would like to penetrate new markets, like the food industry, we need to provide something that its cost is very affordable.
In Singapore, scientists are studying a different source of protein for space travel, microalgae.
You know, there are several fossil records already confirmed that the first few plants or even animals on planet Earth, they were actually descendants of microalgae. So think about that. So microalgae really is the genesis of all the living things. And because of that, they encompass all the needed nutrients. What are those nutrients? We're talking about fatty acids, omega-3, DHA, EPA. We're talking about all the essential amino acids our human body cannot create it. We're talking about lutein, chlorophyll, astaxanthin. We're talking about vitamins.
Nature teems with microalgae, but Wang's method of growing it boosts yield and requires fewer resources. In a fermentation tank, microalgae feed on spent grain, soy pulp, or okara, and molasses. Harvested after 3 days, the crop is dried and milled into a protein-rich flour. Changing the growing formulas and the nutrients on which the microalgae feed could produce flavors that mimic those of familiar foods.
And then once they finish the growing process, we will then make it into powder, dry it, and then that will become pretty much just like any of the protein powder you have on Earth. You then could be using it to make a milkshake or even make it into a tofu on the spacecraft if you have enough machines. What a bioreactor does is actually they provide an environment for these microorganisms to grow efficiently. Inside the bioreactors, we have the control, say for example, the temperature, the aeration, you know, how much oxygen, how much carbon dioxide is in the liquid or in the air part. What you see here, that, you know, that's how we envision that how the astronauts are going to grow our microalgae as food using a bioreactor like this. If we can grow the foods even on the other planet and on that tiny crowded spacecraft, what would it mean for us to grow it on this planet, on planet Earth? That means that we can grow it very, very sustainably and very, very efficiently on this planet Earth.
Now operating in the Netherlands, Wang hopes to run studies aboard the International Space Station. His earliest collaborator was A-STAR's Singapore Institute of Food and Biotechnology Innovation. For Singapore, a city seeking by 2030 to satisfy 30% of its nutritional needs locally, new and sustainable forms of protein are much welcomed.
Singapore is a small urban city-state. We believe that food science and biotechnology are critical in addressing constraints such as lack of land. As such, we have been working in the microbial protein space to build a pipeline of alternate proteins for our future.
My family in Taiwan been fourth generation Buddhism, been making vegetarian food for 3 generations. I believe a lot of these processed foods can be done healthier. And it is actually the answer, the solution to make the space foods. Because quite frankly, you can't get the whole chicken farms into the spacecraft, right? So the only way is to use the new technology, like the one we developed, which is microbial fermentation, or the cultivated meat and seafood technology. You know, the more challenges, the more questions, problems, the more meaningful my work can be. And so that's why I started Solvis Bionutrients. That's how I dedicated my whole life into this.
In Wageningen, Dr. Wieger Wamelink is onto a new dietary alternative for humans that's more commonly used as pet food.
Well, I'm opening the cabin now and removing the sheets, because in here are the mealworms. And they are fed on Martian crops. So we've grown the crops that they eat on Martian soil simulant, and we're trying to find out if they can survive on this. Well, they're still alive. You can see them moving, so that's okay. Now, what are the mealworms doing? They're eating. That's their main business, of course. And they're eating Martian crops at the moment, but you can also see small little grains in them, and that's their poo. So it shows that they have been eating over the weekend, and I hope they grow from it.
Mealworms could feed on crop waste and fertilize soils, making them a circular and sustainable source of protein.
If you go outdoors here, the worms are almost gone in agriculture areas. So we want the mealworms to live on waste product, organic waste product. And if we can get that going, then it not only will benefit people living on Mars, but also here on Earth.
In 1975, this observatory opened for business. Dr. Wieger visits to deepen his knowledge of astronomy.
Hi, Alex.
Hallo, Wieger. Welkom op de Volkssterrenwacht Bussel.
Ja.
This hobby inspired his research into food in space.
I'm fascinated by space, but especially by the planets, and then again by Mars. And one of the biggest adventures in this century for mankind is to put a man and a woman on Mars, to explore how the planet is and how it is built. Well, my interest in space started already as a child. In the library, I looked up all the books that are available, especially about the planets, and read about it. And then already I got very interested in do work on the planets. And now that has become a reality. Well, if you're going to live on Mars and the Moon, you have to eat. That you can't do without. And I think, especially when we go to Mars, already the first people that will go there will grow their own crops. Otherwise, the mission will, I think, not be possible. And also, when we want to have a settlement like the ISS, but then on the Moon, we will grow our own crops there. So that will be the future there, to provide your own food where you live. The prime goal of our experiments is, of course, to set up something for Mars and for the Moon. But we are learning a lot, also applicable on Earth. What we're actually doing is reinventing agriculture because everything has to be circular.
Japan experiences around 1,500 earthquakes a year. Most are minor. But in 2011, a real shakedown hit Sendai. The quake registered at 9.1 on the Richter scale.
で実際に、ここは海沿いの町で、後ろ側にはすぐ住宅地があった場所になります。でこの住宅地は津波の影響を受けて
Shimada Masayuki was 28 at the time. He and his family lost their home and lived for 6 months in a shelter.
また地域には障害を持たれている方たちもたくさんいます。そういった方たちが、避難所に行くということはですね、想定をなかなかしていなかった当時はですね、彼らが本当に右手におにぎりと左手に食パンみたいなですね、炭水化物中心の避難所生活、それからの避難所の生活っていうのはハイカロリーなものばっかりでですね、バランスが取れなくってですね。
Shimada decided to change that. He created an emergency food already in stockpiles around Japan, ready for use when the next quake hits.
ライフストックゼリーが耐圧試験をやってます。これは宇宙認証の中でも耐圧検査っていうのを要求されます。つまり大気圏に行くときに圧がかかってしまうので、それに耐えれるか。
The jellies, which were originally made for use as emergency food, are being considered as a potential space food. They're produced to strict specifications. They must stay bacteria-free and have at least a 5-year shelf life.
そうですね。単純にゼリーということであれば、なかなかカロリー取れるのかなということなんですけども、実はもうこの一つのですね、1袋200キロカロリーを摂取することができるので、いわゆるおにぎり1つ分をですね、摂取することができる。それをですね、また宇宙の空間も実はですね、宇宙飛行士の方たち相当忙しい時間の中で、かなりタイトな時間の中でミッションを実行しなければいけないという、その限られた短い時間の中でエネルギーをチャージするという意味ではですね、宇宙の空間でも片手で、ワンハンドでですね。
The idea to develop livestock jellies as a food for space travel began with the Bosai Space Food Project. That venture was a joint effort of the Japan Aerospace Exploration Agency and One Table.
そうですね。その宇宙という極限環境、人がそういった環境に強いられるという中で、実はその部分的にその災害避難所の生活っていうところと、類似点がいくつかあるんじゃないかっていうそういった視点からですね。
基盤の予算と思えば応援する。しかもすごく資源もない環境の中で技術もしくは知見を伸ばして、でそこで作り上げた究極的な技術とか知見で地球上の課題解決を加速する、そんなことを考えています。
There are 3 flavors now: pear, grape, and apple and carrot. More are on the way.
我々もちろん子供であるとか老人の方たちからはですね、もう通常に普通の商品として美味しいというふうにですね、備蓄品とですね、災害商品でいうとなかなか災害とか備蓄商品というのは美味しいみたいなイメージがなくってですね、これ普通に美味しいねと、日常の時でも子供たちが食べられるような味になっていると。
ブローの部分、赤と黄、オレンジと赤とオレンジと赤。どこで食べたい？ソーダで食べる。
そして被災地の課題を解決することがひいては宇宙の QOL の向上につながる、こういったミッションで宇宙防災食というものを我々は推進しているというふうに思っています。
技術のテクノロジーの力を使って、未来志向を持ってですね、課題を解決に向かっていくというのが宇宙技術振興だと思ってます。片一方でこの被災地もですね、災害を受けた時には、断水になる、水が断水になったり停電になったりということでインフラが全て止まってしまうんですね。そういった意味では実は宇宙空間の課題を解決していくということは実は被災地の現状の解決になっていく。
Space is big business worldwide, worth $424 billion in 2020. Once solely the domain of governments and aerospace enterprises, space has now become a general business sector. And Singapore is moving to make itself a global hub for this industry. Lynette Tan is CEO of Singapore Space and Technology Limited. The company organizes the Global Space and Technology Convention.
Space is going to be ubiquitous in our economy. You know, it's a key enabler in driving the transformation in many of today's sectors, such as the transport sector, the energy sector, the agriculture sector, sustainability developments. And it's also an enabler in developing new innovation and pushing developments in emerging technologies of tomorrow.
One of the things that I see as a great impact for Singapore is being a hub, being geographically located in a strategic position within Asia to have access to exchange ideas, talk about challenges, and find new areas of opportunity for collaboration.
Going forward, NASA will continue to engage internationally in a wide array of matters to make sure that our missions are successful. We cannot do without international cooperation, and our missions will not be successful if we don't have extensive international collaboration.
How many of you here have ever met an astronaut? If you're interested in space, you can actually...
Space has become a place of great interest, even among teenagers at school. These Singaporean students recently visited Japan. They had won a competition sponsored by JAXA, or the Japan Aerospace Exploration Agency. At JAXA, the students ran an experiment under microgravity conditions at the International Space Station.
Earth is just a tiny dot in the middle of a very big map, and I think there's a lot to learn, there's a lot to see, there's a lot to find out there. So that's why I think that it's really important to us.
Here is a mock-up of Japanese experiment module on the International Space Station.
It's quite interesting because when it's a simple pendulum, I can only go...
Back in school, they report their findings. Their double pendulum experiment tested how such a device would work as a robot arm extending from a spacecraft.
If we're going over long distances, there has to be some sort of reliable planting methods. And such mechanisms, such as the double pendulum, can help ease this effort, perhaps by grabbing onto seeds and then planting them into the soil somehow.
I've always been confined to thinking within the Earth's gravity, and it just unlocked a brand new area of exploration for me to know that this gravity is just, we can change it, and depending on how we change it, we have unlocked a brand new of possibilities.
Actually having our experiment selected and seeing it done in space also sort of gives us a sort of accomplishment in a sense, right? That we actually done it. I think it's just a small step in our life, right? So I think, well, this will certainly spur us on. We certainly hope that there are bigger things to come.
Man's continuing quest to explore new frontiers has inspired countless innovations and possibilities. technologies and techniques developed and tested in space could reboot agriculture, making food production more sustainable on Earth.